The understanding of the National Electrical Code, or NEC, is correct in this scenario. The overcurrent protective device, or OCT, determines the ampacity of the circuit, not the wire size itself. National Electrical Code Article 210.19 A1 states that the ampacity of a conductor shall not exceed the ampacity of the overcurrent device protecting the conductor. In the situation described, there is a 20 amp OCT protecting number 10 THHN wire. This complies with the National Electrical Code because number 10 THHN wire has an ampacity of 30 amps, which is greater than the ampacity of the OCT. The lead man's assertion that there is a violation of the National Electrical Code is incorrect. The installation is in compliance with the National Electrical Code because the ampacity of the conductor is not exceeded by the ampacity of the OCT. The industrial-grade receptacles being used are rated for 20 amps and can accept wire sizes up to number 10. This means that the receptacles are compatible with the number 10 THHN wire that is being used. The circuits do not have any motor loads, which means there is no need to consider motor starting currents when determining the ampacity of the circuit. In conclusion, the installation is in compliance with the National Electrical Code. The wire and OCT have been correctly sized for the load that is being served. To elaborate further, it's essential to understand the fundamental principles that govern electrical installations as outlined in the National Electrical Code. The primary goal of the NEC is to ensure electrical safety by providing guidelines for the proper selection and installation of electrical equipment and wiring. This includes specifying the appropriate wire size, overcurrent protection, and other safety measures to prevent electrical hazards such as fires and shocks. The concept of ampacity is crucial in determining the correct wire size for a given circuit. Ampacity refers to the current carrying capacity of a conductor, which is the maximum amount of current, in amps, that a conductor can safely carry without exceeding its temperature rating. The ampacity of a conductor depends on several factors, including the type of conductor material, its size, its insulation type, and the ambient temperature in which it is installed. The National Electrical Code provides tables and guidelines for determining the ampacity of different types of conductors under various conditions. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rated ampacity of the conductors, the overcurrent device will trip or blow, interrupting the flow of current and preventing damage to the wiring and equipment. The size of the overcurrent protection device must be carefully selected to match the ampacity of the circuit conductors. If the overcurrent device is too large, it may not trip quickly enough to protect the wiring from overheating and potential fire hazards. If the overcurrent device is too small, it may trip unnecessarily, causing nuisance outages. The National Electrical Code specifies the maximum allowable overcurrent protection for different types of conductors and circuits. In the specific scenario described, there are two 20 amp circuits that are 200 feet away from the panel. Number 10 THHN wire is being used for these circuits, and industrial-grade 20 amp receptacles are being installed. The question arises whether the use of number 10 THHN wire with 20 amp receptacles violates the National Electrical Code, given that number 10 THHN wire has an ampacity of 30 amps. The key to understanding this situation lies in recognizing that the overcurrent protection device, in this case a 20 amp circuit breaker, determines the ampacity of the circuit. The fact that the number 10 THHN wire has a higher ampacity than the circuit breaker does not violate the National Electrical Code. As long as the ampacity of the wire is equal to or greater than the rating of the overcurrent protection device, the installation is considered safe and compliant. National Electrical Code Article 210.19 A1 explicitly states that the ampacity of a conductor shall not exceed the ampacity of the overcurrent device protecting the conductor. This means that the wire must be able to safely carry the amount of current that the circuit breaker is designed to protect against. In this case, the number 10 THHN wire can safely carry 30 amps, which is more than the 20 amp rating of the circuit breaker. Therefore, the installation meets the requirements of the National Electrical Code. The use of industrial-grade 20-amp receptacles is also appropriate in this situation. These receptacles are designed to handle the amount of current that the circuit is rated for, and they are compatible with the number 10 THHN wire that is being used. The fact that the receptacles can accept wire sizes up to number 10 does not mean that they are required to be used with larger gauge wire. As long as the receptacles are rated for the current that the circuit will be carrying, they are suitable for the application. It is important to note that the National Electrical Code also specifies requirements for voltage drop in electrical circuits. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to the resistance of the wire. Excessive voltage drop can cause equipment to operate inefficiently or even fail to operate at all. The National Electrical Code recommends that voltage drop in branch circuits should not exceed 3%, and the total voltage drop from the service entrance to the farthest outlet should not exceed 5%. In the scenario described, the circuits are 200 feet long, which means that voltage drop could be a concern. Using number 10 THHN wire helps to minimize voltage drop compared to using smaller gauge wire. However, it is still important to calculate the voltage drop to ensure that it is within the allowable limits. There are several online calculators and software programs that can be used to calculate voltage drop. To perform a voltage drop calculation, the following information is needed: the length of the circuit, the current that the circuit will be carrying, the wire size, the wire type, the voltage of the circuit. Once the voltage drop has been calculated, it can be compared to the allowable limits to determine if the wire size is adequate. If the voltage drop is too high, a larger wire size may be needed. In addition to voltage drop, there are other factors to consider when selecting wire size for electrical circuits. These factors include the ambient temperature in which the wire will be installed, the number of conductors in a raceway or cable, the type of insulation on the wire. The National Electrical Code provides tables and guidelines for adjusting the ampacity of conductors based on these factors. It is important to consult the National Electrical Code and other relevant standards to ensure that the correct wire size is selected for each application. In summary, the installation described in the scenario is in compliance with the National Electrical Code. The use of number 10 THHN wire with a 20-amp circuit breaker and 20-amp receptacles is appropriate, as long as the voltage drop is within the allowable limits. It is always a good idea to consult with a qualified electrician or electrical engineer to ensure that electrical installations are safe and compliant with all applicable codes and standards. Furthermore, consider the specific application and load requirements when selecting electrical components. While the National Electrical Code provides minimum requirements for safety, it may be beneficial to exceed those requirements in certain situations to improve performance or reliability. For example, using a larger wire size than required can reduce voltage drop and improve the efficiency of electrical equipment. Similarly, using higher quality receptacles and other components can improve the longevity and reliability of the electrical system. In addition, it is important to properly install and maintain electrical equipment to ensure its continued safety and performance. This includes following manufacturer's instructions for installation, regularly inspecting wiring and connections for damage or corrosion, and promptly addressing any electrical problems that may arise. Regular maintenance can help to prevent electrical hazards and extend the life of electrical equipment. It is also important to be aware of any changes or updates to the National Electrical Code. The NEC is revised and updated every 3 years to reflect advancements in technology and changes in industry practices. Staying informed about the latest code requirements is essential for ensuring that electrical installations are safe and compliant. There are several resources available for staying up to date on the National Electrical Code. These include attending training courses, reading industry publications, and consulting with qualified electricians and electrical engineers. By continuously learning and improving your knowledge of electrical safety and code requirements, you can help to create a safer and more reliable electrical environment. In conclusion, understanding the National Electrical Code and its requirements is essential for anyone involved in electrical installations. By following the guidelines and recommendations outlined in the NEC, you can help to prevent electrical hazards and ensure the safety of people and property. Remember to always consult with qualified professionals when designing or installing electrical systems, and to stay informed about the latest code requirements and best practices. The NEC isn't merely a set of rules, it's a comprehensive guide that incorporates decades of experience and research in electrical safety. Its purpose is to standardize electrical practices across the board, ensuring that installations are performed safely and reliably, regardless of the location or the specific application. One of the key principles underlying the NEC is the concept of coordination. Coordination refers to the proper selection and installation of electrical components so that they work together effectively to protect the electrical system and prevent hazards. This includes coordinating the ampacity of conductors with the rating of overcurrent protection devices, as well as coordinating the voltage ratings of equipment with the voltage of the electrical system. Proper coordination is essential for ensuring that the electrical system can safely handle the expected loads and that overcurrent devices will trip quickly and reliably in the event of a fault. The NEC also addresses a wide range of specific electrical applications, from residential wiring to industrial installations. It provides detailed requirements for wiring methods, grounding, bonding, overcurrent protection, and other aspects of electrical systems. The NEC also includes specific requirements for special occupancies such as healthcare facilities, hazardous locations, and swimming pools. These special occupancies have unique electrical hazards that require additional safety measures. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include local building codes, state electrical codes, and industry standards. It is important to be aware of all applicable codes and standards when designing or installing electrical systems. Compliance with all applicable codes and standards is essential for ensuring the safety and legality of electrical installations. The NEC is not a static document. It is continuously revised and updated to reflect advancements in technology and changes in industry practices. The NEC is typically updated every 3 years, with the latest edition being published in 2023. The process of updating the NEC involves input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, inspectors, and consumers. The proposed changes to the NEC are reviewed and debated by technical committees, and the final version of the code is approved by the National Fire Protection Association, or NFPA. Staying up to date on the latest edition of the NEC is essential for ensuring that electrical installations are safe and compliant. The NEC is available in print and electronic formats, and there are numerous training courses and resources available to help people understand and apply the code requirements. In conclusion, the National Electrical Code is a comprehensive and essential document for anyone involved in electrical installations. By understanding and following the requirements of the NEC, you can help to prevent electrical hazards and ensure the safety of people and property. Remember to always consult with qualified professionals when designing or installing electrical systems, and to stay informed about the latest code requirements and best practices. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any decisions about electrical installations. Ignoring safety standards, cutting corners on materials, or failing to obtain necessary permits can have serious consequences, including fines, project delays, and, most importantly, increased risk of electrical hazards. Therefore, it is always recommended to prioritize safety and compliance over cost savings or convenience. Moreover, it's crucial to remember that electrical codes and regulations are not static. They are constantly evolving to address new technologies, emerging safety concerns, and lessons learned from past incidents. Staying updated on the latest changes to the NEC and other relevant codes is essential for ensuring that your electrical work remains compliant and safe. This can involve attending training courses, subscribing to industry publications, and participating in professional organizations. Continuous learning and professional development are vital for maintaining competence and staying ahead of the curve in the ever-changing field of electrical work. Remember, electrical work is not a do-it-yourself project for the uninitiated. It requires specialized knowledge, skills, and experience to perform safely and effectively. Hiring a qualified and licensed electrician is always the best option for ensuring that your electrical work is done right and meets all applicable codes and standards. A qualified electrician will have the necessary training, tools, and expertise to handle any electrical task from simple repairs to complex installations. They will also be familiar with local codes and regulations, and they will be able to obtain the necessary permits for your project. In addition to ensuring safety and compliance, hiring a qualified electrician can also save you time and money in the long run. They can identify and resolve potential problems early on, preventing costly repairs and delays down the road. They can also help you choose the right materials and equipment for your project, ensuring that you get the best value for your money. So, if you're planning any electrical work, don't hesitate to call a qualified and licensed electrician. It's the best investment you can make in the safety and reliability of your electrical system. Finally, let's consider some common misconceptions about electrical work that can lead to dangerous situations. One common misconception is that all electrical wires are the same and can be used interchangeably. In reality, different types of wires are designed for different purposes and have different ampacity ratings. Using the wrong type of wire can lead to overheating, insulation damage, and even fire. Another misconception is that it's okay to overload electrical circuits as long as the circuit breaker doesn't trip. Overloading circuits can cause the wires to overheat, which can damage the insulation and create a fire hazard. It's important to distribute electrical loads evenly across multiple circuits to avoid overloading any one circuit. Another misconception is that ground fault circuit interrupters, or GFCIs, are only needed in bathrooms and kitchens. GFCIs are designed to protect against electrical shock by detecting ground faults, which can occur in any location where water is present. GFCIs should be installed in all wet locations, including bathrooms, kitchens, laundry rooms, and outdoor areas. By understanding and avoiding these common misconceptions, you can help to prevent electrical hazards and create a safe electrical environment for yourself and others. Remember, electrical safety is everyone's responsibility.